All right, this will be the Helicopter Flying Handbook, Chapter 2, Aerodynamics of Flight. We're on page 19 of 28, at the bottom at Transitional Lift, going into page 20. Transitional Lift. Improved rotor efficiency resulting from directional flight is called transitional lift. The efficiency of the hovering rotor system is greatly improved with each knot of incoming wind gained by horizontal movement of the aircraft or surface wind. As the incoming wind produced by aircraft movement or surface wind enters the rotor system, turbulence and vortices are left behind and the flow of air becomes more horizontal. In addition, the tail rotor becomes more aerodynamically efficient during the transition from hover to forward flight. Figures 3-37 and 3-38 show the different airflow patterns at different speeds and how airflow affects the efficiency of the tail rotor. Effective transitional lift, ETL. While transitioning to forward flight at about 16 to 24 knots, the helicopter goes through effective transitional lift. As mentioned earlier in the discussion on transitional lift, the rotor blades become more efficient at forward airspeeds increases. Between 16 and 24 knots, the rotor system completely outruns the recirculation of old vortices and begins to work in relatively undisturbed air. The flow of air through the rotor system is more horizontal. Therefore, induced flow and induced drag are reduced. The angle of attack is effectively increased, which makes the rotor system operate more efficiently. This increased efficiency continues with increased airspeed until the best climb airspeed is reached and total drag is at its lowest. As speed increases, transitional lift becomes more effective. Nose rises up or pitches up and aircraft rolls to the right. The combination effect of the symmetry of lift, gyroscopic precession, and transverse flow effects cause this tendency. It is important to understand these effects and anticipate correcting for them. Once a helicopter is transitioning through ETL, effective transitional lift, the pilot needs to apply forward and left lateral cyclic input to maintain a constant rotor disc attitude. Got some pictures. So now that was page 20, you go on page 21. Transitional thrust. Figure 3-37. The airflow pattern for 1 through 5 knots of the forward airspeed. Note how the horizontal vortex is beginning to dissipate and induced flow down through the rear of the rotor system is more horizontal. Figure 2-38, an airflow pattern at a speed of 10 to 15 knots. At this increased airspeed, the airflow continues to become more horizontal. The leading edge of the downwash pattern is being overrun and is well back under the nose of the helicopter. Transitional thrust. Translational thrust. Translational thrust occurs when the tail rotor becomes more aerodynamically efficient during the transition from hover to forward flight. As the tail rotor works in progressively less turbulent air, the improved efficiency produces more anti-torque thrust, causing the nose of the aircraft to yaw left with a main rotor turning clockwise and forces the pilot to apply right pedal, decreasing the angle of attack in the tail rotor blades in response. In addition, during this period, the airflow affects the horizontal components of the stabilizer found on most helicopters, which tends to bring the nose of the helicopter to a more level attitude. When a helicopter is hovering, the tail rotor is operating in very disturbed airflow. As the helicopter achieves ETL, effective transitional lift, the tail rotor begins to generate much more thrust because of the less disturbed air. The helicopter reacts to the increased thrust by yawing. Therefore, as a helicopter achieves effective transitional lift, you must reduce tail rotor thrust by pedal input. At about the same time, you need to make your cyclic adjustments for lateral tracking, acceleration, and climb. Induced flow. As the rotor blades rotate, they generate what is called rotational relative wind. This airflow is characterized as flowing parallel and opposite the rotor's plane of rotation and striking perpendicular to the rotor blade's leading edge. This rotational relative wind is used to generate lift. As rotor blades produce lift, air is accelerated over the foil and projected downward. Anytime a helicopter is producing lift, it moves large masses of air vertically and down through the rotor system. This downwash or induced flow can significantly change the efficiency of the rotor system. Rotational relative wind combines with induced flow to form the resultant relative wind. As induced flow increases, the resultant relative wind becomes less horizontal, since angle of attack is determined by measuring the difference between the chord line and the resultant relative wind. As the resultant relative wind becomes less horizontal, angle of attack. Transverse flow effect. As a helicopter accelerates in forward flight, induced flow drops to near zero at the forward disc area and increases at the aft disc area. These differences in lift between the fore and the aft positions of the rotor disc are called transverse flow effect. This increases the angle of attack of the front disc area, causing the rotor blade to flap up, and reduces angle of attack at the aft disc area, causing the rotor blade to flap down. Because the rotor acts like a gyro, maximum displacement occurs 90 degrees in the direction of the rotation. The result is a tendency for the helicopter to roll slightly to the right as it accelerates through approximately 20 knots or in the headwind, or if the headwind is approximately 20 knots. Transverse flow effect is recognized by increasing vibrations of the helicopter at airspeeds just below ETL on the takeoff and after pushing through ETL during landing. To counteract transverse flow effect, a cycling impulse to the left may be needed. All right, got some pictures. We're going to hold off there. That's page 22 of 28. What was on the last page? All right. Yep. We'll hold off there on page 22, 28. There was a transverse flow effect, induced flow, transitional thrust, effective transitional lift, ETL. All right. Good. Went right there at page 22. See ya.